Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome back to Electromagnetic Field Theory. In the previous video, we have derived the expression for electric field intensity due to uniform infinite sheet of charge. We derived the formula for E bar is equal to rho s upon twice epsilon 0 A n cap in volts per meter. We have seen that this electric field intensity formula is not dependent onto the distance between the field point and the source point, which was not the earlier case for the line charge and that of the point charge. Now, based on this concept, let us solve two numerical statements. So, the first problem statement is the problem statement is three infinite uniform sheets of charge are located in free space as follows. 3 nanocoulomb per meter square at z equal to -4, 6 nanocoulomb per meter square at z equal to 1 and -8 nanocoulomb per meter square at z equal to 4. Find E bar at the points PA, PB, PC and PD. Now to read the problem statement, what information we supposed to get? Now in the problem statement, directly it is stated that there are three infinite uniform sheets of charge. Okay. In the previous video, what formula we have derived, we will be using that particular formula to get the electric field intensity. But here the sources of electric field are three. That is why there will be three different electric fields existed into the surroundings. Now because of three electric fields, there will be the summation we have to make to determine the net or the final electric field intensity at the field point. Now these are the values of sheet of charge densities or surface charge densities, what we denote rho s. So let us say this is rho s1, this is rho s2, this is rho s3 in the space, and the field point having the coordinates in terms of xyz values, as no one of them is in degrees. So it is rectangular coordinate representation. So look at the given data and what is to be determined. First of all, draw the diagram, which will be very essential so that we cannot make any kind of mistake while calculating the answer. So let us draw the diagram first of all. So here in the space, we consider z-axis in upright position, y-axis perpendicular to it in the plane of the paper, and x-axis perpendicular to it like this. Outwards is positive side from the plane of the paper. This is y, this is z. Now see, all the three infinite uniform sheets of charge are having the locations with respect to z values. X and y are not mentioned. So these are the planes parallel to xy plane or z equal to 0 plane, we can say. So now the first infinite uniform sheet of charge is located at z equal to -4. So from the origin, which is the intersection of x, y and z axis, I have to go for z equal to -4. So -1, -2, -3 and -4. So here the sheet is present. So let us draw a small plane. I can show you like this. So this dimension must be parallel to x. So let us say this is x dimension, this is y dimension, which intersect here at z equal to -4. So this has rho s1, I say rho s1 is equal to 3 nanocoulomb per meter square. So this is infinite along positive and negative of x, infinite along negative and positive of y also, okay, but z is equal to -4, that is fixed. So this is infinite uniform sheet of charge represented by this one. Now the second sheet has rho s2 value 6 nanocoulomb per meter square. It is situated at z equal to 1. So at z equal to 1, so in the positive side I have to show like this. There will be another plane, okay, having x and y dimensions in infinites, and cut z at z equal to +1. it is having rho s2 given by 6 nanocoulomb per meter square. Now the third infinite uniform sheet of charge is denoted by Z equal to 4, having this value. So at Z equal to 4, in the positive side 1, 2 unit, 3 unit and 4 unit. Here there is another sheet of charge. So I denote it rho s3 having the value minus 8 nanocoulomb per meter square. This is Z equal to 4 value. So there are 3 sheets having uniform distribution of charge. They are having infinite dimensions of x and y situated on z axis at minus 4, plus 1 and z4. So this picture should be clear to us. Now we are asked to determine the net electric field intensity produced because of these 3 different sources of electric field at the field point. First of all, let us take the case of PA 2 phi u minus phi u. So I locate the point 2 phi u minus phi u in this diagram. So 2 units on x-axis, 5 units on y-axis, 1, 2, 3, 4 and 5. I take the lines parallel to x and y intersection. This will be 2, 5 and 0, and then minus 5. The z coordinate is having the value minus 5. So I lower it down. Okay. As this sheet is at z equal to minus 4, the point is required to have the coordinates 2, 5, minus 5. It should be below this particular sheet. So we get the point that denoted by PA having the coordinate 2, 5, minus 5. So now if you see the diagram, the point PA is below all these 3 sheets of charges. Now because of the uniform infinite sheet of charge, the electric field intensity is given by the formula what we have derived. It is equal to rho s upon twice epsilon 0. Rho s already given to us for the 3 sheets. Epsilon 0, 2, these are the constants. It is associated with a n cap. This is normal direction, normal to the plane in which the sheet is present. So the sheet is along x and y direction. The sheets are parallel to xy plane. So the normal direction will be either in the positive z direction or negative z direction. If the normal direction is in the positive direction, we have to select az cap. If it is in the negative, we have to select minus az cap. So now from the source to the field point. So this is first source, this is second source, this is third source. The field point is here. So from the first source, I have to select this direction. From the second source, again I have to select this direction. From the third source also I have to select this direction. All are downwards. That is why for the 3 cases I have to select minus az cap directions. So now determining the exact E vector, I put E1 bar for first sheet of charge plus E2 bar for second sheet of charge, E3 bar for third sheet of charge, which will give us after summation the net E field. So for electric field produced at point PA due to first sheet of charge, I write rho s1 upon twice epsilon 0 an1 cap plus rho s2 upon twice epsilon 0 an2 cap plus rho s3 upon twice epsilon 0 an3 cap. So as we have discussed, all the directions from first, second and third sheet of charge are downwards. I have to take minus az cap into consideration. So now simultaneously I substitute the values of rho s1, rho s2, rho s3 and an1, an2 and an3. So here I make 3 into 10 raised to power minus 9 upon twice into 10 raised to power minus 9 upon 36 pi as the value of epsilon 0. An cap is minus az cap. So this is the first term. The second term will be 6 into 10 raised to power minus 9 upon 2 into 10 raised to power minus 9 upon 36 pi into minus az cap. This is the second term, and the third term will be, it will be minus 8 into 10 raised to the power minus 9 upon 2 into 10 raised to the power minus 9 upon 36 pi, and again the direction will be minus az cap. So now we have substituted all the values for the three terms to get the net electric field intensity at the field point PA. So field point PA is here. So after getting the calculations, the final value will be capital E bar is equal to minus 56.4716 Az cap. The unit of measurement will be volts per meter. The problem statement was find E bar at the point. So at point PA we have the answer E bar is equal to minus 56.4716 Az cap in volts per meter. Now let us plot the point PB having the coordinates 4, 2, minus 3 and also determine E bar. So for plotting the point PB, again we take the diagram. So in this diagram, let us mark x is equal to 4 units, 1, 2 already there, 3 and 4. Then 2 units on y-axis, 2 units here. So I shall be drawing the parallel lines to x and y-axis. This is the intersection point having the coordinates 4, 2. We will put 0 here. Now we want z equal to minus 3. So we shall be lowering it down by minus 3 units. Now see, the first uniform infinite sheet of charge is having intersection with z-axis at z equal to minus 4. This point PB has z equal to minus 3, so it has to be somewhere like this, above this sheet. So the PB having the coordinates 4, 2, minus 3. Now in the three-dimensional diagram, this point is below these two sheets of charges and above this sheet of charge. So hence, because of the first sheet of charge, the point is upwards. That is why we should be selecting upward direction, that is Az cap, positive Az cap. Because of second sheet, it will be downwards, and because of the third sheet, it will be again the downwards. Hence, we rewrite the formula, that is E bar for point PB to be equal to E1 bar plus E2 bar plus E3 bar. So this will be rho S1 upon twice epsilon 0 AN1 cap. Similarly, rho S2 upon twice epsilon 0 AN2 cap, and rho S3 twice epsilon 0 AN3 cap. So here we put the values of rho S1, rho S2, rho S3, that is 3 into 10 raised to the power minus 9 upon 2 into 10 raised to the power minus 9 upon 36 pi. So AN cap for the point PB will be upward, that is positive Az cap. For the second one, it will be, here it is 6 into 10 raised to the power minus 9 upon 2 into 10 raised to the power minus 9 upon 36 pi will be the same. This will be minus Az cap. And for the third term also, 8 into 10 raised to the power minus 9 upon 2 into 10 raised to the power minus 9 upon 36 pi into minus Az cap. So upon making these calculations, E bar we obtain, that I write capital E bar, that is electric field intensity at point PB having the coordinates 4, 2, minus 3. We get the answer E bar is equal to 960, sorry, E bar is equal to 282.3582 Az cap volts per meter. So this is the required answer for part B of this problem. So part B has this answer, 282.3582 Az cap, unit is volts per meter. Now let us focus on to the part C. So for part C, we have PC point having coordinates -1, -5 and 2. Z coordinate is 2. Okay, so let us plot it into the diagram. So in the diagram we have the point is -1 unit on x-axis, -5 units on y-axis, so it should be somewhere here, intersection, and then 2 units to be lifted up. So here it is the point PC having the coordinates -1, -5 and 2 unit. Now x and y are infinite for the uniform sheets of charges. So it is no matter what the x and y value is there, z value 2 gives us the exact location of point, whether it is between the two plates or out of that. So here z equal to -4 with respect to this first sheet of charge 2. So it is upwards. So for PC the direction of AN cap will be upwards, that is AZ cap. Because of second sheet, the second sheet is situated at z equal to 1, but it is having z equal to 2 greater than that. So again it is upward AZ cap. The third sheet is situated at z equal to 4, whereas where the point PC is at z equal to 2. So it has to be downwards direction. So plus AZ cap plus AZ cap minus AZ cap combination we have to take. So for this point, that is PC, we shall be writing capital E bar is equal to E1 bar plus E2 bar plus E3 bar. Correspondingly we have, let us take common part outside, 10 raised to power -9 upon 2 into 10 raised to power -9 upon 36 pi to be the constant portion. Then 3 times AZ cap, first AN cap, then 6 times AZ cap minus 8 minus AZ cap will become plus 8 AZ cap. So finally we can have the value 960.0180 AZ cap volts per meter. So this is the required answer of electric field intensity due to 3 infinite uniform sheets of charges given at the point PC. Now the last portion of this problem is PD. The coordinates are -2, 4, 5. So again we locate that point, we plot that point into this diagram. The coordinates are -2 units on x-axis, -1, -2, then 4 units on y-axis. Okay, the intersection somewhere we can have it here. Okay, the diagram has become more complex. Now z coordinate is important to us. Z is equal to 5. So I have to lift this point by 5 units. Now see, the first uniform infinite sheet of charge is located at z equal to -4. This is at z equal to +1. This is at z equal to +4. But the coordinate has z coordinate, but the point has z coordinate equal to 5. So this point is above all the 3 sheets of charges. Hence, the direction of AN cap to be selected for electric field intensity due to first sheet will be upwards, due to second sheet will be again upwards, due to third sheet will be again upwards. So AZ cap, AZ cap, AZ cap. Hence, the electric field intensity at point PD in part D, we can have E bar is equal to E1 bar plus E2 bar plus E3 bar. The common portion we can write 10 raised to power -9 upon 2 into epsilon 0 value, 10 raised to power -9 upon 36 pi. Now in bracket 3 AZ cap upward direction plus 6 AZ cap upward direction plus -8 of the surface charge density and AZ cap -8 and upward direction AZ cap. So we finally get 56.4716 AZ cap, unit is volts per meter. This is the required answer for part D. So part D answer is 56.4716. Now, if we focus on to the results of part A and part D, the magnitude is same, only the direction is reverse, because the first point was below all the three sheets of charges, the last point is above all the three sheets of charges. So it becomes clear that on which particular side of the sheet of charge the point is located, no matter how far that particular point is, because the sheet of charge we have considered is infinite. The two dimensions x, y here were infinite. So this way we are solved with this problem 1. Thank you.